summary, to add fractions, you add the numerators but keep the denominators the same. For example, 3/7 plus 2/7 is equal to 3 plus 2 over 7 or 5/7. So I'm adding the numerators, but everything is over 7. The denominator stays the same throughout. Using algebra, where A is one number, B is yet another number, and C is yet another number, where C is not equal to 0, A over C plus B over C is equal to A plus B over C. We're adding the numerators, but keeping the denominators the same. To subtract fractions, you subtract the numerators, but keep the denominators the same. For example, 6/9 minus 4/9 is equal to 6 minus 4 over 9, which would be 2/9. I'm subtracting the numerators, but keeping the denominators the same. All the denominators are 9. Using algebra, where A is one number, B is yet another number, and C is yet another number, where C is not equal to 0, A over C minus B over C is equal to A minus B over C. So I'm subtracting the numerators, but all the denominators are the same. They're all C. Counterexamples. Well, what are counterexamples? A counterexample is an example that shows that a concept is not always true. It is an example of the case of where the concept is not true and therefore shows that the concept cannot be always true. I would like to note that a counterexample does not prove the concept never happens. It simply shows that it does not always happen. I plan to go over 2 counterexamples for 2 cases. The first case is that the mistake of thinking that adding fractions means you keep the numerators the same but add the denominators. This is false, and I plan to provide a counterexample to explain why this is not true. The next counterexample I plan to provide is the idea that adding fractions means you add the numerators and add the denominators. This is also false. And again, I plan to provide a counterexample for this case. Well, let's get on with the first counterexample. Does 2/6 plus 2/5 equal 2/11? Do I add fractions in this way of keeping the numerators the same but adding the denominators? Well, first of all, let's get 2/6. 1/6, 2/6. Then let's get 2/5. 1/5, 2/5. Then let's get 2/11. 1/11, 2/11. Now let's combine 2/6 with 2/5 and see if they are equal to 2/11 when I add them together. In other words, does 2/6 plus 2/5 equal 2/11? So I'm combining 2/6 and 2/5. And then I look and compare them to 2/11. So here is 2/6 plus 2/5, and here is 2/11. And as you can see, 2/6 plus 2/5 is a lot bigger than 2/11. Therefore, 2/6 plus 2/5 is not equal to 2/11. And therefore, you do not add fractions this way of keeping the numerators the same but adding the denominators. Does 3/8 plus 6/12 equal 9/20? Do I add fractions in this way of adding the numerators and adding the denominators? Well, first of all, let's get 3/8. Now let's get 6/12. Now let's get 9/20. So let me now combine 3/8 with 6/12 and see if the total of 3/8 and 6/12 is equal to 9/20. This will determine if 3/8 plus 6/12 is equal to 9/20. The total of 3/8 and 6/12 when I combine them is a lot bigger than 9/20. Therefore, we can know that 3/8 plus 6/12 is not equal to 9/20. Therefore, you do not add fractions by adding the numerators and adding the denominators. So what should you do when you need to add fractions with unlike denominators? It does not seem that you can add these fractions because the denominator has to stay the same throughout. So what you would do is that you should make the denominators the same. So how do I make the denominators the same? You can multiply both the numerator and denominator by the same number. For example, for one fraction, I may multiply both the numerator and denominator by 3. In another fraction, I may multiply the numerator and denominator by 5. Why can I do this? I plan to explain in a later set of videos why you can multiply the same number to both the numerator and to the denominator and have it equivalent to the original fraction. And when I create that future set of videos, I plan to have it linked in the description of this video. Thank you for watching this set of videos. I hope that you enjoy them.